Hello. In this video, I would like to share a technique that can be used to solve a triangle for missing side lengths and angle measures. While simple trigonometric functions can be used to solve right triangles, non-right or oblique triangles require a little more work. For the purposes of this lesson, we will use capital letters to represent angles and their measures. We will use lowercase letters to represent sides and their lengths. When solving oblique triangles, we must be given at least 3 of the 6 measurements, one of which must be a side length. The law of cosines cannot be used to solve every oblique triangle. In fact, it may only be used in the following 2 cases. The acronym SAS stands for side, angle, side, and it indicates the 3 provided measurements are 2 side lengths and an included angle measure. An included angle is one that is between and connected to both of the provided side lengths. The second case for which the law of cosines applies uses the acronym SSS, which stands for side, side, side. In this case, all 3 side lengths are provided. The law of cosines states the square of one side length is equal to the sum of the squares of the other side lengths and the opposite of twice the product of the other side lengths and the cosine of the opposite angle measure, which is a bit verbose and very difficult to memorize. Fortunately, it is usually accompanied by the supplied equations, and with practice you will recognize these are modified forms of the Pythagorean equation. Let's use this information now to solve the first triangle below. Since our objective is to identify all side lengths and angle measures, I'd like to start by writing down the provided information. We have an SSS triangle, so we must use the law of cosines to solve. It does not matter which form of the law of cosines we use, since all 3 sides are provided. I'll start with the first and let you complete the other 2 on your own to finish. Side length A is 17 feet. Side length B is 11 feet. And side length C is 10 feet. So the equation looks like this. You should notice that on the right side of the equation, we used b squared and c squared, then subtracted 2 times the same b and c values. Finally, we finished with the cosine of a, which is the same letter used on the other side of the equal sign. Each of the other forms of the law of cosines are built the same way. I like to do all of the algebra I can first without using the calculator. So I will now subtract 11 squared and 10 squared from both sides of the equation. Then I will divide by -2 times 11 times 10. Finally, I will use arc cosine to evaluate for the missing angle measure A. It is helpful that I am using a calculator that displays this entire expression all at once, but it is entirely possible to complete this on a plain scientific calculator. Be careful with your use of parentheses and the order of operations, and you will compute the correct answer as well. Now try the other two on your own. If you would like, you can modify the previous expression to account for the other forms of the law of cosines. Pause the video now and resume playback in a moment to check your work. Here we see the work necessary to compute the other missing angle measures. And a quick check shows the measures sum to 180 degrees. Using the law of cosines in the second example is a bit more tricky. Here you see the angle measure A and the side lengths B and C are provided, making this an SAS triangle. I think I would solve for side length A using the first form, then solve for the remaining angle measures using the others. To solve for side length A, we can take the square root of both sides of the equation and set up a new equation that looks like this to solve. To find angle measure B, we can set up the second form of the equation and use algebra to solve. Similarly, we can find angle measure C. A quick sum of the angle measures shows 180 degrees, and the sizes of each side length corresponds to the size of each angle measure. I would say these solutions look pretty good. To finish this video, I would like you to identify the type of triangle that is presented and identify which law must be used to solve. At the very end of the video, I will show the solution to each so that you can practice solving these and check your work. Good luck.